Hello everybody. So I hope you have worked on the previous problem that I gave you. So what I'll do is I'll give you another one and then we'll work on this one in the next lesson. I just want to see how much progress we're making. So please write the solutions in the comment section. Tell me what you're finding and then we'll solve it. If you want me to solve it, let me know as well. If you don't, then just tell me. Let's move on to the next one. So number 5 that I want you to do is that the cubic expression x to the power 3 plus ax to the power 2 plus 7x, okay, plus 7x, and then plus b, this is b, leaves a remainder 2 when divided by x minus 3 and a remainder 1 when divided by x plus 2. So find A and B. Okay, so work on this, pause the video, work on it, tell me what the solutions will be. What you're supposed to find is A equals negative 13.8 and B equals 78.2. So whatever you find, let me know. If you find the answer as well, please let me know in the comments that you found it, and then yeah, I'll confirm that in the next video, or how to solve it, that is. Now let's look at something, the final part of this topic, and then we'll transition to the next topic. Now let's look at algebraic polynomial identities. Okay, or algebraic identities. So we're talking about identical polynomials. So I think we'll not take long on this. I just need to go straight to an example. So if A, example 1, if A, let's do that. Okay, if x to the power 2 plus 6x plus 7 is equal to x plus a squared plus b, find the value of a and b if it is an identity. Okay, so they're telling us that if x squared plus 6x plus 7 is equal to x plus a squared plus b, this is a b, and then they're saying find the value of a and b if it is an identity. Now when they're talking about an algebraic identity, they're telling you that there are two algebraic expressions. There may be polynomials or quadratic expressions, whatever they may be, but they're telling you that these types of polynomials, they are identical, meaning they are exactly the same, exactly. Okay, so they want you to find the missing terms in the other one, knowing that it's an identity with another polynomial where you know everything, every coefficient that is given. Now we'll write that down here. X squared plus 6x plus 7 equals x plus a squared plus b. And you know what we're supposed to do. We need to simply expand this. So it will be x squared plus 6x plus 7, plus 7 equals, then x plus a, and then x plus a, and then plus b. Okay, so x squared plus 6x plus 7 equals, then we put it there, it's actually x squared plus ax plus a squared, and then plus b. All right, so it's x squared plus 6x plus 7 equals, and then that becomes x squared plus 2ax plus a squared plus b. Okay, now that's what we're ending up finding as our expression on the right hand side. Okay, that is our expression on the right hand side. Now, how we're going to manipulate this is very easy. Now, I want you to identify something. They're saying these things are identities, meaning they're identical, they're exactly the same. Now, our main variable is x. Okay, this expression has a variable of x, this one also has x. That means a and b are coefficients. They are constants. Okay, now where do we have x squared in the other expression? Is here. Here there's a coefficient of 1, here there's also a coefficient of 1. Then where is the second term with simply x to the power 1? Here is this one. Okay, here there's a coefficient of 2a, here there's a coefficient of 6. So if these things are identities, we'll say therefore 2a equals what? 6. Why is it equal to 6? Because it's at the same position as in the other expression. So it means those two coefficients must be equal. So this becomes 2, wait a sec. This becomes a equals 6 divided by 2. This gives us 3. So I'll find the value of a. All right, can you see that? All right, now, so from there, we also are seeing that the final term in the other one, where we know everything, is actually 7. But here we have a squared plus b. That means the remainder of this, since these things are identities, the thing that is remaining here, the whole thing, is actually equal to the constant term in the other one. So it means, therefore, a squared plus b equals 7. Therefore, a squared plus b, let me just write it properly. We know actually, we have already calculated a. So it's 3 to the power 2 plus b equals what? 7. This becomes 9 plus b equals 7. Okay, and that becomes b equals 7 minus 9, giving us what? -2. That should be your answer. Okay, so this is what you do when you're dealing with identities. Simply know that the coefficients or the various variables should be equal. So if you have an expression like this at the end, when you have already matched the other variables, just know the whole expression equals to the remaining term in the other one. That's what it means to deal with identities. All right, now let me give you something that you can do at your own spare time. Number 2, find the values of the letters in the identity x squared plus 3x plus 5 equals x plus h to the power 2 plus k. All right, so they want you to find the value of k and h. That's what I want you to find. All right, so thank you so much for tuning in today. Don't forget to like, to comment, and also to subscribe. Tell me what your solutions will be to both the problem I gave you at the beginning and also this one. Thank you so much.